Okay, so do you want to do like a 1 or 2 minute intro about like who you are, like where you're working? You don't have to do anything specific, and like what level engineer you are, how many years of experience, that type of stuff.
Yeah, I have seven years of experience as a backend engineer. I'm currently a senior software engineer. So
Oh,
I
nice.
have worked on both on the front end development experience, and I also from my latest 5 up to 5 years experience is majorly on the back end development for a product company.
Okay, cool. And are you like, do you have experience at like startups, big companies, both? Where are you at right now?
No, just the big companies.
Oh,
I
big
know
companies, cool.
startups. Yeah,
Okay, okay. So yeah, I guess you're interviewing for another big company, so that'd be good. Okay,
yeah.
and then what language do you want?
Java.
Okay, so we have a Java pad here. So I'm gonna paste the prompt. So right now it's 7:08, so we'll stop at 7:48. So we'll do the first
Okay.
one. I'm gonna paste a prompt here, and I will give you some examples.
So I'll start reading the question. So
Yep.
you are given an MCAS and integer matrix with the two following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given integer target, return true if the target is in matrix or false otherwise. Uh, Return an integer target. Return true if target is in matrix or false otherwise.
Mhm.
Um, yeah, so my idea is to, since the matrix is already sorted, the idea that comes to my mind is since we already have the sorted numbers, I'm thinking of using binary search will come first to my mind.
Mhm.
So yeah, so I would have to do the binary search and um,
Okay.
target equals 3. For the given example here, I would check. Um, yeah, I will check based on the row, first row. My first filtering criteria will be the row, the first row which I'll filter at.
Mhm.
And I'll check if the first element and the last element of the corresponding row, and if the given target is in between those two numbers.
Mhm.
And once I filter out the row, and then I'll filter out the corresponding column uh, by doing the binary search again on the column that I have encountered. Um, Yeah, that is so. In that case, it will be a logarithmic time complexity, and uh,
Okay, so basically you're saying you're gonna go through each row, and then you're gonna check if the element is in there just by doing like the min and the max, and then if it is, you're gonna binary search the row. Is that correct?
yeah, yeah, yeah. So,
Okay. So
so
that is.
first,
Oh yeah, go
yeah,
ahead. No, you can keep going.
yeah. First, I will filter the row based on the first column in the row and the last column.
Hmm.
And once I filter out the row, uh, then I will filter the I will do the binary search, and I'll do the binary search on the corresponding row once I filter out the row.
Hmm. So so what happens if our matrix is like 50 rows and each column is one? So it's just like, like 1, 2, 3. So with your solution here, you're gonna go like row by row by row, right?
Yeah,
And
yeah,
so the binary search doesn't really help you for the row because there's only one element. So is there a way
yeah,
you can make a better binary search
yeah,
where you're including both?
yeah. Let me think. So
Mhm.
Yeah, so if each row has one element, so I would,
And obviously, like, one or two or whatever, but I'm just giving you an
yeah,
extreme
yeah,
case, like where you're still linearly searching through every row. So how can we optimize that as well?
okay. Yeah, in that case, basically what I'll do is I will consider the low has, yeah, so I'll have the first element in the matrix, which is the lowest element,
Hmm.
and the max is the last element in the matrix,
Hmm.
and I take the mid element, and uh, yeah, even in that case, it will be based on the row level.
Yeah. So if you had, so you're basically saying if this matrix was like going back to like number 16 or line 16, the low would be one and the high would be like 60. And you'll take
Yeah,
that as
yeah,
like the min and the max. Okay. And you'll take the
yeah, yeah,
middle.
yeah. I'll take the middle, and
Okay. So how do you know where the middle is? Like, yeah, like obviously if you have the numbers, you can like, if this is like index zero and index whatever, like,
yeah, yeah,
what is
yeah,
this, like 11? It'll be like index five, but how do you know like where that is? Because it's not a one row, it's multiple rows.
yeah. Okay. So yeah, in the matrix, we always have all the elements, right? We wouldn't be missing anything.
We wouldn't be missing anything, but like if you go back to line 16, right? So for example,
Yeah,
your left would be like zero.
yeah,
You like if you just go by index, or you're going to go by index or by number, or like what would that be? Like, are you saying
yeah.
like
Index.
this
Let's.
index? Okay, so like
Yeah,
there's total elements like 12 or whatever, so right would be like 11, right?
yeah. So the way I'm thinking is,
Uh-huh.
I will have the low as the index. So
Uh-huh.
I have index zero, and high has the total number of elements. If I have five
Sure.
cross five matrix, I have 25 elements.
Yeah.
So, and in that case, I would have to find the mid element, which will be 12
Mm-hmm.
approximately. So how do I find out which row it belongs to? So
Yeah.
I would just have the length of the matrix,
Mm-hmm.
and if I have the length, so if I do the mod operation,
Mm-hmm.
if I divide it by the length of the matrix, so then it will have the corresponding row.
Uh-huh.
Which
Okay,
will
so
be
that would give
what
you the
is,
row, and then how do you find
yeah,
the column? Or are you going to binary search through the row?
yeah, yeah. Um,
Like, can we find the column, or do we have to binary search through the row? Like, if you have this example, right, zero, let's say there's like 26 elements, 0 to 25, you get 12. Like, how do
Yeah,
I know?
again,
How
I
do I
have to
know
do
where
the
this is
binary search for that operation.
for the column?
For the column, I have to do two binary search operations, one for the row and one for the column. Uh,
Oh, I see. So you're
yeah,
saying, you're gonna binary search for which row it's in, and then
yeah, yeah,
once you know
and
what
then
row it's in, you'll binary search the call. Like, okay.
column.
So in this
Yeah,
example, if the target was three, for example, on 16, so you'd binary search, you'd go for like the middle. Okay. So here you're basically saying if you get the row, it'd be like zero and two, right? Like these are all the rows. That's what you're saying.
yeah, yeah,
Okay, so you binary search the row. So you try like the middle one, and then you'd say it's not there. So you'd get like row is zero or something, and then from there you'd search the column, binary search the column.
yeah, yeah.
Okay, and what's the time complexity for that?
So it will be logarithmic time complexity.
Yeah, so
It
if
will be
if
log of n.
a log of what? Sorry.
Log of n.
So can you write it like if
Yeah.
if 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 like we have m rows and n columns, like what would it be?
Um,
And use both variables if you can. So like you have m
it will
rows and n
be m
columns.
rows and n columns. It will be m into n. Log of m into n.
Okay. I think that is. not 100% sure. I feel like it's this. Maybe I'm wrong. So like this is the row, right? And then to get the column, it's this.
Oh yeah,
So I
yeah.
think it would be this instead.
Yeah, if you have log mn, it will be log of m plus log of n, so it's the same thing.
Yeah. Okay. So okay, that sounds good to me. So I think we can start coding.
Okay. So we have to return boolean and
Yeah, and if you're doing like the meta type thing, you can if you want to just get rid of the whole class solution, just write a function. Totally fine. We're not going to run anything. You'll just go
okay,
through what it's doing. So whatever you prefer is fine.
yeah. Um, so I have a matrix with uh,
Hmm.
and I have
And you have a target value as well in your input. Okay.
so I have to calculate the length of the matrix and I calculate the breadth of the matrix and
Hmm.
so um, at the end I'll just return false and so now I have to do um, so low will be the first element and high will be the number of elements which will be length into breadth.
Okay.
So if I have a matrix with 3 cross 3, so then I have 9 elements, so that will be the high and so I have to calculate low less than.
So you said in your like code you're going to find the row first and then the column. So why would the high be the whole thing? Like, aren't you just looking through rows in the beginning, or are you
Yeah,
looking through every element?
yeah, I think
Okay.
so this will be the length and um, I will calculate the mid, so which will be low plus high. So, so now I have the mid element. I
Hmm.
have to check. Um, so now I have the mid element. So which gives me um, the corresponding row. So I would just fetch. Um, so this will be matrix of mid. Um, if so now I have to decrement either the low or the high based on if let me check like this. So this will be row of 0. Um, is less than target and else. So I have to check if target is less than is greater than target. So in that case, which will be I equals mid, um, else low equals mid plus 1. Yeah. So now I filtered out the high I equals, which will be high equals mid. So that will be the corresponding row. And
So this will be the corresponding row. So if it's
I think the
too
was
big,
low equals mid.
okay.
Now,
Not 100% certain that works, but we can try it. Okay. Okay, so basically you're saying like if the row is too big, then chop off the top half, and if
yeah,
the
yeah.
row is,
Otherwise, I would consider the low from the mid and high to the.
do you
Uh,
not need a like a base case where like you found the row? Like, does this work? I'm not 100%. You know what I mean? Like,
yeah.
because right now you're saying if it's too low, do something. Otherwise, just go the other way. So what if it's equal?
Right. Yeah. So of 0 and so this will be less than or equals to, and this will be less than or equals to. Um,
You just can't have both in one if statement. It's a syntax error in Java. You need separate. So you need like and the other thing.
yeah. Okay. Yeah. In that case, I would just return to that corresponding row which is made. If not, we will just do this. I'll just add this in the helper function.
Oh, okay, so you'll just get like a find row or something. Sure.
Yeah, and so once I have that, so now I have to do the binary search again on the column. So um, here again I have to so return. So this will be 0 and the column which I am iterating. I think I'll modify this at a later stage. So I'll just
Okay.
so this will be mid of row and I already calculated the length and width of the matrix. I'll just pass in here. And
Okay.
so now I will check. So the mid of the low plus mid of the element, and I'll check the mid uh, new mid. So if it is target, I'll just return true. If not, at the end, I'll just return false.
Okay.
And so low equals mid. This is other way around. Yeah, at the end we'll just return. So this will be boolean value, and we'll just return if it is if the matrix contains. So I have to pass the matrix to. So yeah, find column matrix row number which will be mid. Yeah, row and length and width and target.
Okay. So I don't know if you've seen like the red stuff, but yeah, you have a few bugs. So.
Yeah, so I'll just I'm passing the target in matrix values here. Um,
Okay.
so I have to pass some matrix and target. Low, high, and so yeah, I think this should take care. Yeah,
Okay. Let's just move on to the second question because
okay,
yeah, this is a little over 20. So I just want to give you time.
yeah,
So let's do that one and I will paste it as well below this one and then I'll give you feedback for both afterwards.
okay, okay.
Okay, so the second question.
I'll read the question. So I have 8 minutes. Find all valid combinations of k numbers that sum up to n such that the following conditions are true. Only through 1 through 9 are used. Each number is used at most once, such that sum up to n, such that the following conditions are true. Only numbers 1 through n are used. Each number is used at most once. Written a list of all possible valid combinations The list must not contain the same combination twice, and the combinations may be written in any order. Yeah, so for the given example, 1 plus 2 plus 4 equals 7. There are no other combinations.
Hmm.
Um, so all the k numbers should be present. Okay. Uh, so the second example, we have 1 plus 2 plus 6, 1, 3, 5, and 1. The third example is k equals 4 and n equals 1. There are no valid combinations. Okay, so basically we are doing combinations and find out the target which sum up to the given target value, and I have to find the different combinations of the numbers.
Yep.
Okay,
And I'll
so
just
I
give
do
you the
see.
function signature to save you some time, so you can
Yeah,
just write it in
okay,
here. Call
okay,
it main or whatever.
yeah. I'll, so should I explain further, or I'll just try to?
Yeah, I'd like to, yeah, before you code, just explain like what you're
Okay,
doing.
okay. So um, I have to find the combinations of the numbers such that it finds the total value n, which is uh, n,
Hmm.
and so given n, that means if I have n digits in the so if n equals, if int n, that means I can consider all the values up to if for example this particular case, if I have n equals 3, so
Hmm.
then I would have all the values uh, until 2 or 3, I think.
So n is the number you're trying to sum up to, and you have numbers 1 through 9 always.
Oh, okay, okay, okay.
And then you can just use any one of those numbers 1 through 9. You need k of them
Yeah,
to make
yeah,
n.
yeah.
So yeah, so if n is 3, like the only one would be like 1 and 2. Or if n is 3 and k is 2, then it would be 1 and 2.
Okay,
If n is 3 and k is anything other than 2, well, I guess k is 1, it would be 3. But if k was like 3, it wouldn't be possible. So you would just return
yeah,
an empty array.
yeah. Um, so I'll maintain an index where for the start of, I'll have a for loop here. For example, I'll start from uh, 1 through 9, and each time uh, for the helper function, I'll have a index from where I'm starting it,
Hmm.
and uh, so the next subsequent element will be the index. When I consider, it will be if I have, let's say if I start with 0 as the index, and if I consider the 0th element,
Hmm.
and for the next time I would consider elements more than 0. It can be 1, or it can be 2, or it can be 3, or anything.
Hmm.
uh, i'll s- i'll I'll add them into the list each time,
Hmm.
and I'll keep a count of, so I can find the calculate the list of elements in each time when I'm doing the operation, when I'm adding the numbers into the list.
Hmm.
And I'll also keep a parameter sum, such that each time when I'm adding into the list, I'll keep a count of the sum of the values of which I've already included in the list.
Hmm.
At any given point of time, if the sum is greater than n, I would just return it. If not, um, I'll consider, if at any given stage the length of the size of the list is equal to k, and the sum of the existing members in the list is equal to n, I will
Hmm.
just add into the result list, which I am keeping it as a global variable.
Hmm. Okay, and just to double check one thing, so you said you're going to be adding to the list, and you're going to be adding it to the results and stuff. Are you removing from that list as well, or just adding to it? So you're like, you said you were like adding
Yeah,
numbers to a
yeah.
list and stuff. So are you going to
Yeah,
remove
so
them as well?
basically, I would have to backtrack when I'm adding the list, or I also need to backtrack those elements.
Cool. And then what's the time complexity for that one?
Yeah, so it's since we are doing the backtrack operation, and
Hmm?
um, it will be a factorial time complexity.
Okay. Yeah, I mean, for what it's worth, backtrack with a K and stuff is pretty complicated, so I think I'll just
Yeah,
factorial sounds fine to me.
yeah,
It's going to be like pretty complicated to calculate, so that's good.
yeah.
Okay. Yeah, let's get to coding.
Okay. So I have the list, and I'll have one more helper here, and I'll pass the k n k comma n comma result. Um, and I have so at the end I'll just return the result of public void. So this will contain so int k and the result and a list of integers so far which I have added into the temporary list, and I'll also have the sum. That means if at any given stage, if sum is greater than um, n, in that case uh, I would just return, and so I would so far I would also keep track of the index. uh, so this will have the index of 0. We start with 0.
Hmm.
So here I equals index, and I less than um, or equals to 9, and I plus plus. Um, so again I have to calculate. So if at any given point of time I have to find the size is greater than the k, I would just break out of the loop.
Hmm.
I would just return, and if I would calculate uh, temp dot size is equal to k, and sum is equals to n. In that case, result dot add new list of the temp which I have added so far, um,
Hmm.
and so rem dot add this will be high, and I would just remove the corresponding elements. Dot size minus 1, whatever the element I have added, I'll remove it.
Hmm.
So here um, I would need to consider whatever the index, I would need to consider the subsequent index, and k and n will be the same, and result will be the same, and some passing the temp. Index plus 1 kn result temp. So the sum will be sum plus um, the index I. Um,
Okay.
yeah, and so here also I don't need to go further. Um, so I want to make sure that
Yep. What are you trying to make sure?
um, yeah. So yes. So since I am doing it separately, Yeah, I think yeah, this should work because if I don't want to be adding same element, so in the next iteration I'm increasing the index, so it won't be considered. The next subsequent elements will be considered, and
Hmm.
yeah.
Okay, could we do a like a dry run if you're happy with this on maybe one of the examples?
So k equals 3 and
Yeah, just pick whatever one you want to do. That's
okay.
reasonable.
So we have k equals 3, n equals 9, and
Hmm.
so so we start with the index 0. So um, I think I don't need to consider 0. It has to be 1. So if
Hmm.
I start with 1 and if I had 1 to the 10, and so the helper function will start, the next subsequent iteration will be, um, so if I call this again, it will go to the next, um, yeah, so next time when I come here, I'm adding the index, but I also removing the index, um, removing the item from this, and so if I have, if for the next subsequent iteration, if I have, um, if I say index equals 2, so then I will
Hmm.
add the happy path as index 2,
Hmm.
and so the next iteration, so I also be modifying the temp at each subsequent iteration.
Hmm.
So if I consider 2 as the next element, and if at a subsequent iteration, if I had 6, if I consider 6, then my temp will have the 1 to 6 as the list of list. Temp will contain 1 to 6, and for the happy path I'll check the sum will also be 1 plus 2 plus 6, which is 9 each time when I'm incrementing.
Hmm.
um, so at this particular stage, at line number 188, so we have the times dot size equals 3 and sum equals 9, so we'll add it into the result. Similarly, we will catch the cases for all the cases, sum up to n,
Yeah.
and we have the result will return the result after all the iterations.
Okay. Yeah, I think this is good. Okay. Um can you see how I'm trying to think if this would optimize it. It would a little bit, I feel like. So is there another way we could write this part? Like you have this for loop, right, where you're like starting at your index and you're going to the end of them and you're adding or not
Mhm.
and then you're recursing. So is there another way we could have written this maybe that did the same thing? Because essentially for every number you're just saying like add it or don't, right? So is there another
Yeah,
way we could
yeah,
have done it?
yeah. So maybe you could have a Boolean array considering which elements we have added so far or which elements we have.
I meant more in terms of just like what we could have done. It was like instead of having a for loop, we could have just like because you're storing an index, right? So you can just like
Yeah,
for this index, add it and recurse to the next one, or don't and recurse to the next one. And that might have been maybe a little better. I think it doesn't matter too much because the input's small. So honestly, this is fine. I think. Okay, so let's
okay.
just do the feedback because we're like 2 minutes before the
Yeah,
deadline here. Okay, so let's see here. So let me go back. Okay, so for the first problem, you did like restate the problem. You didn't really ask about edge cases. The one that I
yeah,
would ask is, can we have an empty matrix? I think that's just like free. I don't think
mm,
I said you can't. So you could either ask, and then I'll say like yes or no, and then if it can't be, then you don't check for that. Or if it
yeah,
can, then just write that in your code. That's like a 5 second question that I would
yeah,
just ask. The other one is you did come up with an approach quickly, the binary search through I believe you said linear scan the rows and binary search, so that wasn't optimal. So I had to like guide you a little bit.
yeah,
Um,
yeah.
which is fine. You were also a little bit inconsistent in kind of like which one you wanted to do. Like, do I binary search through all the elements? Do I binary search through each row? For what it's worth, both would work. So
Yeah.
I guess asking you. So basically, the way you could binary search through all elements is you can calculate or own a column from a matrix cell. So you could
Mhm.
have done like like you said like 0 to 11, get a number and calculate or own a column. Done that. Do you think they're equivalent, or do you think one is better? I guess I can ask you now for like more how much understanding you have.
Um,
And does it make sense
I
what I
think it
said?
won't bet I think it won't be any better, I think, because
Is
we are
one better than the other, or are they the same? Like
I think the
if I
same.
binary
I think
search,
the same.
let me give you another example. So your
Okay.
solution versus binary searching through a 1D array with all these numbers, uh, are they the
Oh,
same time complexity or not?
um, no, this solution is better than the 1D array because we will be filtering out the rows and again we'll be filtering out the columns. I think this is optimal.
Yeah, exactly. Okay, so you did realize that. Good. So
Yeah.
yeah, I think originally you said like I want to do like 0 to whatever 11, and I was like that's gonna be
Yeah.
worse.
Yeah.
But I think either would be passing because they're kind of close. The linear scan through the rows, considering this is like a pretty easy problem, I would probably say would like I just wanted to push you towards a more difficult one because like it's already a pretty easy problem, so I wanted to go for kind of like as optimal as I can, and you did
Yeah.
figure it out, so that was good. Um, I think your biggest problem was during the coding, you had a lot of like slight bugs. For
Okay.
example, like your breadth is off by one. You didn't check for the empty matrix. I think the high is off by one. Like you have a lot of
Yeah.
off by ones.
Yeah. Yeah.
Um, Also, I think your find row was not correct. I think you also have like an off by one. So if you go to like 117 and 119, I think these are supposed to be like
Yeah.
mid plus and mid
Mid minus one,
minus.
mid plus one. Yeah. So,
Yeah. And then
yeah.
your I believe 93, 96 should be backwards. So if the item is too big, that means the target is too small. That means
That
that
is right, I think.
you need to go left, right?
Okay. Okay. Yeah.
So I think these need to be reversed.
Okay.
Um, yeah. So basically, that was the biggest thing. Was like your code was pretty buggy, but you did have like the helper functions. But yeah, like I would work on that. Like you had a lot of off by ones and kind of flip stuff. It's not the worst thing. I
Mm.
understand you could see you know binary search reasonably well. You could figure this stuff out. So and obviously you can't run your code. If you could, you can like figure it out better. So there is some room for error.
Yeah.
But you know if you have like 6 bugs, it's not the best.
Yeah. Yeah.
So that was like your biggest problem, and you could have done it a little bit faster. Like honestly, after you finished the first one, I thought you weren't going to finish on time because you
Mm.
were like a little bit over and you didn't really have time to do a dry run for the first one. That's the other thing because you took so long. So
Yeah.
the speed is definitely better. And I do feel like I don't know what your output is, but I do feel like this is like a pretty reasonable question. It's not super difficult. So I do think you should be able
Mhm.
to get this one in 20 minutes if you
Mm.
like prep a little bit more. Okay.
Mm.
But overall, I like for this one I would kind of say like slight pass, like you had some mistakes, you took a while, but it was pretty good. So,
Okay.
and then the second one I think you did a lot better. Like after the first one I was like maybe you'll pass, maybe you'll fail and you're kind of running out of time. You definitely kind of redeemed yourself, I feel like in the second one.
Yeah.
Um so you yeah, I guess there wasn't too much like edge cases in this one, and you did ask me about the example, and then I clarified a little bit for you, like this is what I mean, so that was good. Also, oh yeah, the other thing was on your time complexities, you were a little bit off for the first one. The log m times. I wouldn't just make generic. I don't think it's great to have generic like it's linear or whatever. Try to use variables and then have an actual equation like I have here on 44. Um,
Yeah. Yeah.
say like this is my variables. I'm gonna go through this and then I'm gonna demonstrate that I know like the time complexity of every
Mhm.
piece instead of just like it's linear or factorial or whatever. Same thing with the second one. You can come up with better than like it's factorial. You can use, dimensions like I have n, I have k. For what it's worth, for backtracking, they are pretty complicated a lot of time. Like it'll be some random like factorial times 2 to the n, whatever. So
Mhm.
for what it's worth, that one's kind of annoying. But like for the first one, you could have had like an exact. You could have said like, oh yeah, I log through the row and then log through the column, so it's like log m plus log n
Mhm.
instead of just saying like it's logarithmic. You know.
Yeah, yeah,
So just more detail is always good. Um, but yeah, so for the second one, you definitely came up with a solution very quickly. You explained it very well. Your code
yeah.
worked. I think you had no bugs. I mean, like obviously you can't run the code, so if I can't see a bug, like I'll just say it's pretty good. Um,
Mhm.
so obviously, like if you run it on leak code, you might have a bug, but like whatever.
Yeah, yeah,
Like for
yeah,
example, here you forgot the sum, but like that doesn't really matter.
yeah.
You know, and yeah, once again, like if you forget some semicolons, if you like whatever, some small stuff, like you can't run your codes. It's totally fine, and you're in
Mhm.
time crunch. You had good variable names. You broke down your like you have a helper function. You broke down all
Mhm.
your stuff. I think the advantage of Java is you do code kind of slowly because it's verbose, but you kind of have to break down your stuff. Yeah,
Yeah.
or else you're just not gonna be able to do it. So Java kind of forces you. So it kind of forces you to
Mhm.
write code that's a little bit better.
Mhm.
Python people
Yeah.
might just stick everything into one function, whatever.
Yeah.
So yeah, and then you basically wrote everything. You came up with all the edge cases. You went through a dry run. You could have made it a little bit more like step by step, but I mean it's a backtracking function that's like 50 steps, so totally understandable
Mhm.
that like you didn't do that. So I would say like out of all these like things, so I'd say like the four areas that I feel like are important. So it's like your problem solving, like how fast given a problem can you come up with an algorithm? And so out of
Mhm.
four, I think you're like at like a 3 or 3.5. I think it's quite good.
Yeah.
Um, at your coding is also quite good, like 3 to 3.5.
Mhm.
I think your knowledge of data structures is quite good, or at least what I tested you on. Like you knew backtracking, you knew binary search, you knew like feel like for binary, you probably did quite a bit of backtracking. I'm guessing because like you have this like result, and then you have like the like this is pretty common, so you kind of knew like what templates look like for different things. So that's also like maybe 3.5. And then I think your communication was also very good. Um, like I could tell what you were doing. It was pretty clear, except for maybe the first one where you were kind of like I had to correct you a little bit, where you were like, "I'm gonna find the
Yeah.
row and then find the thing," and then you were looking for the cell. I think the
Yeah.
biggest things to work on is speed. Obviously, I think that's a, for everyone I've done a mock with. That's like the meta speed. It's very hard for them to finish on
Yeah.
time. That's
Yeah.
like that's
Yeah.
that's the main thing. Speed. Um, once again, time complexity. Be more in detail.
Okay.
Less bugs in the code.
Mhm.
Um, and then yeah, like I think if you write like that's a nice thing that you did. So you wrote down pretty clearly what you were gonna do, and then when you deviated, I kind of pointed it out. So that's why I strongly recommend writing what you're gonna do in good detail, because then I'm like, all
Yeah.
right, this is what you're doing, and if you deviate, I can
Yeah.
point it out to you. If you
Yeah.
didn't, a
Yeah.
lot of people just write like 2 lines of code and they're like, am I good to code? Some people will let
Mhm.
you. I think for meta, they don't even like let you. They'll be like, no, explain it more. But then the problem is
Mhm.
if you were to deviate there, like I don't even know what your plan was, and then I couldn't really help you out. So I think that was all
Yeah.
good. So just the main thing
Yeah.
is just do a little bit more problems and just like speed and code and like a little bit less bugs and a little bit more detail about time complexity. But I think
Yeah.
you're like in a pretty good spot, especially for a text screen. Like I think a text screen, the way they do it is like if they think there's like a 25% chance you pass the onsite or something, they move you on. So if it's
Okay.
kind of close, like they'll move you on, and then you can schedule the onsite like in a month or whatever, and you'll have time to like prep some more.
Okay. Okay. So I've worked a lot actually from 2 to 3 months, and yeah,
Did you start at like zero?
no, not zero, but yeah, uh,
Okay.
yeah,
But I mean, yeah, I can definitely see like, I mean, it's pretty hard to have like a perfect interview, right? So there's always areas that you can improve in. So those are kind
yeah,
of the areas, mostly just speed and
mm,
correctness. Some things I'd
yeah,
recommend that work for me is so you get like the meta problems, and then I literally just like opened up a text coder pad, and I'd be like, all right, here's all the steps I gotta do. I gotta ask like the full clarifying questions, I gotta make a plan, I gotta code it, I gotta like do a dry run. And then I
mm,
literally just like put the problem into like GPT, and I was like, I'm gonna give you all of these like steps one by
mm,
one and like give me a review. So
mm,
like what's my thing, what's this, and then look at your time. And so
mm,
ideally like, if they give you 20 minutes, try to get it done in like 10 to 15. And then make sure
mm.
like that the review you get is like pretty good, that your code is pretty error free and all that other. And you could just do a bunch of problems like that and get a consistent review. Because I feel
Okay.
like during the actual interview, like you're gonna be way more nervous than like a mock or your practice. So you kind of want to
Yeah.
give yourself a little bit room for error. So that's why if they give you 20, try to get them done in like 15 or 10 or something like
Mhm.
that. Because yeah, during the interview is pretty stressful. If it's something goes wrong, you're like, oh my god, whatever. So I think that helps a lot. Is like try to hit a bar that's higher than what they test you on, and then that way, even if you are nervous or whatever, you're still fine.
Mhm. Yeah.
Also, the other nice thing is if so they give you two problems in 40 minutes. I don't think they even tell you like let's move on, so you kind of time yourself. So if you can finish one of them very quickly, then you have a lot of time for the other one, which is also kind of nice. Maybe the first one you do in like 10, and then okay, I have like 30 for the second one, and whatever.
Okay.
So
So they don't ask both the hard questions, right? Because if I end up getting hard questions here for two questions, both the
so
questions
it's
are hard ones, then
very from what I talk to people and from my own experience, it's very random. Like you kind of have to not get screwed. Like you might get super unlucky. There
hmm,
are definitely questions that are harder. On my tech screen, I got asked two mediums. It was like, but
hmm,
then for my on-site, I got asked a medium to hard and then a pretty hard.
hmm,
And I
hmm.
didn't have time to code the second one, but I had like a very detailed like plan of like this is exactly what would happen, and I draw in the plan because we were like running out of time. But because of like
Okay.
the difficulty of the questions was like kind of absurd for 40
Hmm,
minutes, that like I still got to
hmm,
pass.
hmm, hmm.
So, but some people get asked like so for that one, I didn't have time to finish and I didn't have time to code. But for the second one, they gave me like just two solid mediums and I finished both in 30. So it's very dependent on like they have a big bank and some questions take a long time. And some people
Okay.
also it's like the one that I had that was the one that I couldn't finish, it was like the guy's first time doing an interview. So you also have
Hmm,
that, where you might get people who are like less experience or whatever, or just I don't know,
hmm.
having a bad day, and then you might get some tough
Yeah.
questions. You might get
Hmm,
some super cookie cutter stuff. I think they're
hmm.
never going to ask you stuff that's like super easy because I think what they do is like if they look at your packet and everything was super easy from what I heard, then they'll like ask another round because it was like too easy or whatever.
Mhm,
And they also try not to ask hards, but there definitely are hards on there because I got asked, like I said, a hard. Like I got asked
mhm.
something with like two heaps or whatever as like a 20-minute question, and I was like, all right.
Oh, okay,
So
okay.
yeah.
Yeah.
So it is it,
So,
it is kind of random.
mhm. So if this is I mean, if this is a real interview, it won't be a high, right? Definitely.
If this was a real interview, this wouldn't be a hire.
Yeah, yeah,
I
right.
think for a tech screen, it would definitely be a pass.
Oh,
Like
okay.
the tech screen, the bar is lower. Like I
Hmm,
would say, like out of four, this was like a lean higher.
hmm,
Like a
hmm,
solid
hmm.
lean higher. Like you finished the second one with basically no bugs, and the first one you
Hmm.
had bugs, but like I mean, almost no one like from doing these mocks with people. I don't think anyone had like a perfect interview or whatever. Like
Yeah,
I know for
yeah.
me doing mocks with other people, like I get very good results, but I've done like 1,800 leak codes, so that's not like not the average.
Oh, okay, okay.
So it's almost no one does it like perfect, and you'd be
Hmm,
surprised how badly people do. Like if you want, yeah,
hmm.
you can look on my channel. I have like mocks with a bunch of other people, so I think you did quite well.
Okay,
Obviously,
okay.
you can prepare a bit more. There's always like room to improve upon, and for the
Yeah.
on-site, it would be kind of close. Like
Hmm,
maybe this would not be a hire for the on-site, but then you have another like month and a half or whatever to prepare for that. So
hmm, hmm, hmm.
yeah.
Okay. And so you already got an offer from Meta, right, for this?
Yeah, so I got an offer from Meta and from another company that I'm working at now that I took
Okay.
instead. So yeah.
Yeah. And so, do you mind asking, like, how do you prepare for the system design? How difficult was it? So, because I also need to prepare for it.
Yeah, so I would just recommend. I mean, you're on Hello Interview, right?
Yeah, yeah.
Yeah, so I just do those,
Hmm,
watch the videos. You can get some mocks on there as well. Like I did some mocks on there and some other stuff. I think mocks is good because when you do mocks for sorry, when you do the actual company interview, like you get no feedback.
hmm, hmm.
So I would strongly advise getting mocks from like senior staff or whatever. I think if you do mocks and Hello Interview, they do. I think most of those guys are like senior or like EMs or whatever. So
Yeah.
I think that's fine, or any one of those programs. So basically, I just find people to do mocks with and get good feedback because it's really
Hmm.
frustrating like doing it one for a company and then like being like I failed, but I don't know why. They just said it, whatever. So
Hmm.
yeah. especially. Oh, I guess you're interviewing for E5, right?
Yeah.
Yes, that's probably a higher bar as well. Like I was
Mhm.
interviewing for E4,
Mhm.
so for that it's mostly just theoretical. I think for E5 you need practical. Like having done mocks with people for like an E5 bar, it's basically you can't just have theoretical hello interview knowledge. Just most people's feedback, it's like, okay, you're going to use Redis. Well, like, how would you do it exactly? You're going to set up Kafka. Like, how, it's like you have to have
Mhm.
practical experience with at least a few of these things. And it can't
Mhm.
just all be theoretical. So I think that's the main thing that's like different E4
Mhm.
from E5.
Okay. Okay.
Yep. And I also don't run system design mocks. Like I could do it for like a new grad or an intern or something. It's like I could pass mid level, but I'm not at the point where like I can do system design mocks. But for coding, I think I'm like extremely good at it. So
Okay.
yeah, I can do those basically.
Okay. Okay.
Yeah. So if you want to schedule like another mock or whatever, and after your tech screen or whatever, just let me know.
Sure. Yeah. I'll let you know. I'll reach out to you. I do have your number.
Okay. Cool. All right. Best of luck.
Thanks a lot. Thanks a lot for taking the time and providing the feedback. It definitely helps, and I'll work on improving it.
Okay. Yeah, see you.
Thank you.